Right now, your body physically cannot survive without cooked food, and almost nobody realizes how strange that actually is. Every other creature on Earth eats exactly what it finds. Wolves don't marinate a kill. Bears don't roast fish. And yet every human culture ever documented, on every continent, cooks its food before eating it. Without exception. Not language, not tool use, not art or religion. Cooking is the one truly universal human behavior. And here's the part that should genuinely stop you. Our bodies have quietly become dependent on it. Not just because cooked food tastes better, though it does. You cannot physically survive long-term without it. Your jaw generates a fraction of the force a chimpanzee's jaw can produce. Your gut runs shorter. Your teeth are smaller. Your whole digestive system assumes food arrives already softened by fire. This isn't a flaw. It's physical proof that an ancestor made one of the most important decisions in our species' history. We don't even know exactly how it started. A scorched root pulled from wildfire ashes, or years of slow trial and error. But at some point, someone tasted heated food, recognized it as better, and an entire species shifted forever. Let's rewind to what life looked like before any of this, because the before makes the after land so much harder. Roughly 2 million years ago, our ancestors ate almost exactly what a modern chimpanzee eats today. Raw fruit, tough roots, raw bark, occasional insects, all requiring enormous amounts of chewing. A wild chimpanzee spends nearly half of every waking hour just processing food in its mouth. Not hunting, not resting, not socializing, just grinding down fibrous material for barely any usable energy. Harvard primatologist Richard Wrangham actually traveled to Uganda and ate what wild chimpanzees eat, to understand it firsthand. His conclusion was blunt. A human body simply could not survive long-term on that raw ancestral diet. Not, wouldn't enjoy it. Could not physically extract enough energy from it to keep a human body functioning. So something had to change between then and now, something that delivered far more usable energy per mouthful. Wrangham's answer, reached while staring into his own fireplace in 1997, was simple. Cooking. Not meat-eating. Not bigger brains coming first. Cooking itself was the engine behind human evolution. We didn't evolve big brains and then invent cooking. We started cooking and our brains grew because of it. To understand why, you need to see what heat actually does to food at a chemical level. Take a raw starchy root. Its starch sits packed into dense granules. Digestive enzymes can barely access. Apply heat, and those granules absorb water and swell open, a process called gelatinization. What was once locked away becomes suddenly accessible. Same food, same weight, dramatically more usable energy. Protein undergoes something just as dramatic. Raw meat is bound by tough fibers that resist even stomach acid. Heat unravels those fibers into simpler strands your body can break down far more easily. Heat also neutralizes many natural toxins and harmful organisms hiding inside raw food, opening up entire food sources that were genuinely dangerous to eat in their raw state. There's a fourth transformation too, the Browning reaction chemists call the Maillard reaction. The exact process behind seared meat and roasted vegetables tasting completely different from their raw versions. Stack all 4 transformations together, and cooking stops looking like flavor. It starts looking like outsourced digestion. Fire does a real share of the chemical labor before food ever reaches your mouth. And then there's the time saved, arguably the most important shift of all. Once cooked food became routine, chewing time collapsed from nearly half the day down to about 1 hour. 4 or 5 extra hours a day, freed from the mechanical necessity of grinding raw material just to survive. Repeated across hundreds of thousands of years, imagine what that reclaimed time actually made possible. Hunting with more coordination, building better tools, maintaining real relationships within the group, teaching the next generation, sleeping longer and more safely, since fire kept nighttime predators away. The campfire wasn't just a cooking device, it was a security perimeter, a gathering point, a time-generating technology. Now here's the part that should genuinely stop you cold. What happened to the human body physically around this same period? Roughly 1.8 million years ago, something fairly abrupt appears in the fossil record, Homo erectus. A noticeably larger brain, a taller frame, longer legs, and critically, a smaller jaw and shorter gut. That gut change may be the single most striking shift in our entire fossil record. In chimpanzees, the digestive tract is enormous, built to slowly ferment huge volumes of tough plant material. In Homo erectus, that expensive system shrinks dramatically, meaning incoming food required far less processing. In most primates, gut size outweighs brain size by a wide margin. In modern humans, that relationship completely flips. Less gut, more brain, an entire metabolic budget quietly reallocated. Your brain right now consumes close to 20% of your entire body's energy, just idling. Gram for gram, it costs roughly 9 times more to run than an equivalent amount of muscle tissue. Brazilian neuroscientist Susana Herculano Hosel calculated what a human-sized brain would cost a raw food primate. A gorilla would need several extra hours of feeding daily just to support a brain our size, time that simply doesn't exist. The math simply doesn't work for a large-brained animal stuck eating only raw food. There's experimental proof too. Mice fed cooked meat gained noticeably more weight than mice fed identical raw meat. Every other variable held constant. The only difference was whether heat had touched the food first. Of course, a fair account includes where researchers still disagree. Some argue calorie-dense food generally, including raw meat, mattered more than cooking specifically. Others believe brain size tracked social complexity more closely than diet alone. Most researchers now suspect all of these forces reinforced each other simultaneously. The archaeological timeline adds real uncertainty too. Clear fire evidence doesn't appear until much later than 1.8 million years ago. Burned bone and ash in a South African cave date to roughly 1 million years ago. Kesem Cave in Israel shows something more compelling, a reused hearth roughly 300,000 to 400,000 years old, alongside cut-marked, heat-treated bone, suggesting a genuinely dedicated cooking spot, not occasional fire use. Widespread hearths across many sites don't become common until roughly 400,000 years ago. Some archaeologists find that gap troubling. If cooking had been constant for 1 million years, evidence should appear earlier. Others argue small open-air fires simply don't survive geological time, and the gap reflects preservation limits, not absence. That disagreement remains genuinely unresolved among researchers today. What isn't up for debate is what happens to a human body denied cooked food entirely, even today. Long-term studies of people on strictly raw diets consistently show progressive, unavoidable weight loss. The body burns more energy processing raw food than it actually recovers from eating it. Close to half of women on strict long-term raw diets stop menstruating entirely. A direct signal that the body has judged its energy supply too unreliable to support reproduction. A diet that halts reproduction in roughly half the population isn't an inconvenience. It's a path toward extinction. Cooking reshaped more than biology, too. A fire that must be tended forces people to gather and cooperate. Someone tending the fire while another forages held a real survival advantage over anyone working entirely alone. Some researchers believe this is where the earliest division of labor between partners first took real shape. Not romance exactly. A working partnership anchored around a shared fire and shared survival. Consider what happens once people gather around fire in the evening, bellies full, predators kept at a distance. Storytelling becomes possible, passing down which berries were poisonous, which valley had water. Laughter, teaching, connection, all fitting neatly into hours once entirely swallowed by chewing. The fire didn't just feed the brain, it created the actual conditions for that brain to become recognizably human. So the next time you're cooking something at some inconvenient hour, take a second to register what you're actually doing. You're carrying out the oldest, most distinctly human technology in our species' entire existence. Older than farming by roughly 1 million years. Older than written language. Possibly older than language itself. You're repeating something an ancestor was doing around a modest fire on the African savanna over 1 million years ago. An act that shrank your jaw, shortened your gut, freed your time, and protected your nights. It organized your earliest social world and freed enough biological energy to build the very brain you're using right now. Every meal you cook is a continuation of the exact act that made you human in the first place. The principle still holds.